Okay, hi, I'm Alexander. I'm the network manager at Uphone. We're based here in Auckland. We do telecommunication services, as you may imagine from the name and where we come from. And I'm just going to present on a few things I've run into in the New Zealand market using a lot of Mikrotik in the core, in the edge, and serving customers. So I'll just start off with a few general warnings, then a couple of tricks, a couple of things for network reliability, including some recent discoveries I've made with impacts that people have been seeing and ways to resolve them. So if you're using 3CX with SBCs, there's a trick in there for you. And down the end, a little bit of a point back to Janice earlier in the day, talking about careful construction of your NAT rules and looking at some of the documentation, and just some links back to some of the earlier documents that he's put out that have some really useful resource. So the general warnings, first of all, these are still tricks. We're still working around issues in a lot of cases, or working around the way things were actually designed to work. Please don't build your network using these as your everyday solution. It's not good to use up all your little tricks, all your little tools, getting the day-to-day network going. Save some of them for your toolbox for dealing with issues. And there are going to be some side effects if you're doing tricks. Again, a lot of these things, you're working around the way that something was originally built to work. Often you can make it work, but look for the better solution later on. So, the triple NAT trick. This came to me out of a customer we were bringing onto our network. They were bringing in a lot of customers with voice, and they deployed a rather cheap ADSL router that happened to be the cheapest option they had for building in an ATA port into their sites. So they put, ironically, a Mikrotik on the edge, and then they had this little box inside the customer's site to run their phones. The router was trying to be very clever and trying to prevent people who got through a router through a misconfiguration from accessing the web management port. It would return you an incomplete login page. Once you logged in, throw you a 403. Nice and easy way of getting rid of it. And so, while in most situations, if something doesn't want you to access it from the internet, you simply do your pinhole NAT coming in from outside, destination NAT yourself in, source NAT yourself through, you're there on the inside. But occasionally, they get a little bit cleverer, and they go down and they take a look at your host header that you have passed along with your request. What did you type into the address bar? And I've just done an example here with our company website, but you can do this IP address, domain name, whatever. This router was looking in there and said, well, that's not my private IP address. I'm going to reject the connection with a 403. So, did the comparison, does a 403, sometimes did a 401 unauthorized, not this particular unit, but I've seen others that do it. And for many people, this ended up being a blocker. I had a friend who was actually dealing with this hardware initially, and he was unable to get remote management in a lot of cases, and ended up having to do a lot of those truck rolls we were just hearing about in the previous talk. I didn't really feel like regular truck rolls up to Orewa on the North Shore. I live in Papakura, so you can imagine it's about as far across Auckland as you can get while still being in Auckland. So I really, really, really didn't want to go for a drive that much every time they had somebody who had a problem. So I sat down, I put my thinking cap on, and what does it need? So it needs the host header. So my little laptop down here needs to be presenting, or needs to be querying through the web interface the private management IP address. I'm not using that IP address at home, so I can have a bit of a play with it. So in 3 stages, I worked my way through ensuring that the host header preserved right across the network while still crossing over without tunnels. A lot of other solutions you may look at doing tunnels. Some things use MTU issues to try and prevent you there. My issue with this one, and why I think this trick can be quite useful, is that if you've got 80 different customers, they've all got the same configuration, you can very quickly drop the 2 lines of configuration on. You don't have to worry about your NAT bypass rules and everything else for getting through your tunnel. And so you can just hop through there. So in my router, first of all, I type in the normal IP address into my web browser. That goes straight to my router. My router goes, where's that? Stick a NAT rule in. So your destination NAT that to the public IP address at the other end. Adjust the port or whatever as you desire, as long as your host header will be preserved. So whatever you're typing into your web browser is what you would type in on the customer's site if you went on site, did your truck roll, and plugged in. Then on their router, you do essentially the same, destination NAT again, just take your public IP, dump it through, normal port forward sort of thing. And then you do what you do for a pinhole NAT and source NAT yourself back through. And Bob's your grandma. That's right the way through, and you're talking directly to the device. And just for anyone after the fact, the slides will go up. Just the 3 NAT commands you need to dump into your router, or your 2 routers to do it. And the beauty of this is, of course, as I said before, you can just change which target IP address you use for your first destination NAT rule, and then you change your NAT rules at the far end. And I have included in here the, where did I put it? This last step of the NAT rule, the limiting that source NAT through to the IP address you're coming from. These devices will still refuse to connect if you've got your host header right, if you're coming from an IP address not in the RFC 1918 range. So as long as you limit yourself, your private IPs there, you're also stopping other people from, stepping on your ports and coming through and playing havoc with your customers' devices. So with this one, obviously you are again working around things intended to be secure. So making sure that you're limiting your IP address for that is critically important. You're exposing a device or an interface on a device that was never intended for external access. Just like we had recently with our updating of our Mikrotiks, even devices that are the external interface can have security issues. So just be very careful not to open this up any wider than you need to. But if your option is a truck roll or this, I definitely think this can give you a big leg up. So the next little trick I want to talk about is the ability from the Mikrotik to use multiple interfaces for a PPPoE connection, or probably almost any kind of PPP connection, but primarily PPPoE for what I'm using it for. And the various standard circuit deliveries across UFB, ADSL, VDSL can vary and can change between. And maybe while some of the legacy ones were all standardized, they were all untagged or all tagged. With the UFB now, with the optional tagging on pretty much all the connections, provisioning errors can come through a lot easier when somebody clicks the wrong button, types in the wrong entry. Some of the LSPs do it a little bit more manually than others, and so you can run into issues. Or you do a change in the network and you can't time your change to be exactly the same, because Chorus will do it sometime between midday and 7 PM or whatever time Chorus time happens to work out to be. You don't want to be sitting there going, oh, I think they're going to do it in this 5 minutes. Change it. It's not another 3 hours and customers offline. So obviously we had the PPPoA, the Boober and the Uber untagged. They also had the option for the Uber where you could be tagged and VDSL being all tagged, and then the selectable options down there. So Uber to VDSL upgrades, especially if you've been using the PPPoE compatibility mode, they allowed, of course allowed for a long time, or still do, or especially BS2A provisioning errors. Probably dealt with about half a dozen in the last year where it's not coming online, get the diagnostics, no, it's been configured untagged and you ordered it tagged. So with that, very easily we can create our VLAN interface, Ether1 or whichever interface you stick it on, simply a comma-separated list of the interfaces you want the PPPoE dialer to use. It will automatically, whenever it doesn't have a PPPoE session up, it will chop and change between them, alternating. So, tagged, untagged, provisioned correctly, accidental provisioning, somebody made a change, somebody redid the software on the ONT, whatever, this should get it back. But, and with these tricks there's quite often a but, it will rotate through all the options, and it's very useful for avoiding the truck rolls. Your radius server needs to reply in a very timely fashion. I would be saying you want to be in the 3 to 5 second range for it. I've seen it out to about 7 seconds still working. If you're going much past 7 seconds, you will find that it may come up the first time because it happened to pick correctly first time when the interface came up. But after that, if it gets out of it, it's not getting that reply quickly enough, it will have moved on to the next interface, it won't get your reply message, and you'll just see endless connections coming through, alternating between or jumping on the wrong interface. So absolutely you need to have fast responding radius for this, and if you or your wholesale provider, if you're buying the circuits from somebody else, have that, fantastic. It does work very reliably. If you don't have that, or you're concerned that your speed may drop down, I'd recommend only deploying this one when you're approaching one of those changes. Let it come in if you know at that time you're close enough, and then make sure you put a note to take it off, the following day or whatever. If something should happen later on and you have dipped outside that time zone, you will find it gets into a loop and often needs a reboot or a truck roll to turn off the multiple interfaces. So, yeah, a couple of options there for just ways that you can get into a device or keep a device online despite the best efforts of our lovely local fibre companies. So, on the topic of making sure that we are, reliable, working well, obviously keeping our radius fast if you're using the last trick, but day to day we'll see all sorts of things in the network that just don't work and don't seem to work very well. A lot of these things can be related to NAT, especially in the VoIP space where I do a lot of my day-to-day work. Tim, who's in the audience here, rang me up a few weeks ago and said, we've got this customer on 3CX, and every morning their first call of the day doesn't have any audio. Network protocols don't only work or not work at the first thing in the morning. What's going on? I'm like, network protocols definitely don't. It's always the first call. What on earth is going on here? So 3CX, the SBC, traditionally only ever worked over TCP. All the signaling and all the media all tunneled across one single tunnel, either unencrypted or later on encrypted. In the V15 software, and especially the SBC they released at the same time, they split that out. So it would maintain a continuous TCP connection, all the signaling would go over there, and then it would try and send the audio over UDP. Much more, reliable, well, not reliable connection, but much more reliable timing for packets. Don't have to deal with the hacking problems that we did in the past. Really good improvement if you can use it for the speed. Unfortunately, for a lot of businesses where calls are incoming, the call setup will allow the inbound audio to start off before the outbound audio is finished establishing, and therefore we can get the inbound packet hitting the firewall first, and the contract tagging that as being an in-use port for that remote host on the internet. So when the audio started travelling from inside, the Mikrotik would automatically go, I got this random packet, I didn't know there was a connection up, so that port's busied out, and I'll go try something else, usually something around the 1024 range. And so it would be judiciously sending the audio packets up to the server, natting them, it thought correctly, and just nothing was getting through. The server would be rejecting it, going, that's not the port we agreed on, this must be spurious. And the incoming audio was being ignored, going, well, there's no connection up, I'm not going to let you through. So, why was it only the first call? Well, to be honest, if they'd actually waited on the line for 35 seconds, it would have all come back working fine in the first call as well. Who sits on a call for 35 seconds with no audio working either way? Very few people. I'll do it if I'm testing a problem, and that's how I found that out for sure. But customers aren't going to want to deal with this, and 3CX don't provide an easy option to say, nah, UDP doesn't work very well, just don't use it. But it will give up after about 35 seconds, and if it got no audio on the first call, as long as it had a reasonable amount of time, it goes, I got no audio, next time I'm trying TCP. And it would do that through the rest of the day, and then overnight it would do its maintenance, roll its logs, restart its service, forget that it didn't have reliably working UDP, and the first call of the day would break again. But surely we can fix this. Yeah, it's not a hard one. So, go back to our NAT. NAT's the problem. NAT possibly is the solution. Tell it how to deal with the audio. You know, with 3CX at least, you know what port this is going to be coming from. Usually ends in 90, defaults to 5090 if you're in a standard installation. You can select that and change it around. But you can put your public IP address in, that source port coming into my connection, and just say, that's cool, I'll forward that straight through to my SBC. You'll only match one packet a day, in-down first UDP packet on your first connection. After that, contract does the rest of the work. But it sets that up, comes through and works. Brilliant. Problem solved. No troubles. Not so quick. It solves the problem for one endpoint. So if you've got an SBC as your only device on site, or if you've only got one customer at a remote branch office who's got a laptop using the tunnel built into their softphone client, solution. Your problem is solved. If you have more than one who's doing their calls through the softphone client, this doesn't work so well. You're going to have problems because they're all going to try and establish their connections out. They'll be using different ports, and you don't have one known internal host to do it. But provided your SBC is your only one actually doing calls, actually needing to handle audio, that trick will work. I'm still hoping that we'll get some changes either on the Mikrotik side or in contract itself, coming from Linux, where they will note that it's a busy port, but note that it's exactly the same host, exactly the same source ports when you've got your NAT rules set up, and will correctly link up those two ends. But in the interim, if you've got 3CX and you've got customers having first call of the day issues, maybe give this one a go. With your NAT construction, just going a bit more from what Janice was saying, some guidance that he gave in the US mum last year on source NAT, some of which was sort of included in his presentation today, but most of which is different, but some quite useful tricks and rules on there. If you've got static IP address, it's just one of the key takeaways from that. If you've got a static IP address or an IP address you know is going to stick around, if we use source NAT rather than masquerade, helps a lot with some of the reliabilities. Or if you've got multiple connections, different IP addresses, but they're on different ports or different services, source NAT for each one rather than a masquerade using all PPP just helps to ensure that changing over actually identifies that the connection is different rather than still trying to send the traffic out your connection 2 with the IP address from connection 1, which is just going to confuse everything, and if people are doing proper filtering on their networks, won't even get past the first hop. Audio firewall rules where possible, and your NAT rules in order of most frequently matched. Obviously, in some cases, matches have to be after. Make jump rules where possible, where you've got a whole cluster of things. You can match one aspect, send something over to a separate jump chain. Just helps to keep all your packets processing through the least number of rules where possible. And if you've got a known category that you know isn't going to match any of your lower rules, put an accept rule nice up and early. Matches that one, passes on, doesn't have to keep matching down the tree of rules. And the recent PoE switches out of Mikrotik, I've got a couple of these on the lab bench at home in my office. I have one of these I have the power. Make sure for your power ports on the back, if you're using the 100 series PoE switch, your 48 volt connector, just make sure it's using the 2.5mm inner jack. A lot of the ones, if you're going shopping online out of AliExpress, will say they're 2.1, they're compatible, or yeah, they're 2.1, they're compatible. Sorry, I've got them around the wrong way. Get the 2.1mm, they'll say 2.5, compatible with 2.1. Not so much. Some jiggling, careful placement. Don't let anyone knock the switch, or suddenly power will turn off to your 48 volt devices, your AF&AT stuff. But otherwise, it's powered up everything I've thrown at it so far, and stayed up pretty reliably. It's only gone down when I've told it to go down, so usually take that as a win. And the larger 3 series PoE switch, this one I actually prefer a bit. It's got the much nicer IEC connector on the back for power, and a very generous power budget across the whole unit. Again, has powered up everything I've thrown at it. Hasn't been complaining, failing, dying. And so I'll be hopefully posting a bit more online about further findings out of these. I'm ever so hopeful that there may be enough routing performance in this unit to be able to replace essentially a 2011 rack mount, a no wireless model, in sort of a 100 meg connection era type of system, just to bring it down to a one box solution with a nice chunky power supply inside, with a lot more buffer. But we'll see how that testing goes, and I'll be sure to report back online as I see more about that. Does anyone have any questions? It was early when I started, and I don't think I've used up all my time anyway, so if you've got any questions, feel free. No? Well, thank you very much.